Venus, Earth's twin. It's often called that, Venus is our closest planetary neighbor. In size and mass, it's remarkably similar to Earth. But don't let that fool you. Venus harbors a deadly secret beneath its swirling clouds. It's a planet of extremes, a stark reminder of how different planetary evolution can be. Venus is a place of intense heat, crushing pressure, and a toxic atmosphere. It's a stark contrast to our own life-sustaining planet. Yet, in its differences, Venus offers valuable insights into the workings of our own world. One of the most striking features of Venus is its incredibly dense atmosphere. Composed primarily of carbon dioxide, the Venusian atmosphere traps heat with remarkable efficiency. This runaway greenhouse effect has resulted in a surface temperature that's hot enough to melt lead. Imagine standing on the surface of Venus. The air pressure would be 90 times greater than what you experience at sea level on Earth. It would feel like being 3,000 feet underwater. The air itself would be heavy and suffocating, a thick soup of carbon dioxide. The heat would be unbearable, reaching a scorching 900 degrees Fahrenheit or 475 degrees Celsius. That's hot enough to melt lead, tin, and zinc. No spacecraft has ever survived for long on the surface of Venus. The intense heat and pressure quickly destroy even the most robust probes. The extreme conditions on Venus are a direct result of its runaway greenhouse effect. This phenomenon occurs when an atmosphere traps more heat than it radiates back into space. On Earth, greenhouse gases like carbon dioxide contribute to a moderate greenhouse effect, keeping our planet habitable. However, on Venus, the process has gone unchecked, creating an inferno. If the heat and pressure weren't enough, Venus has another trick up its sleeve: clouds of sulfuric acid. These clouds, which blanket the planet, are highly reflective, giving Venus its high albedo. This means that Venus reflects a large percentage of the sunlight that reaches it. The sulfuric acid clouds are a product of complex chemical reactions in the Venusian atmosphere. Volcanic eruptions release sulfur dioxide into the atmosphere, which then reacts with water vapor to form sulfuric acid. These clouds rain down sulfuric acid, but the droplets evaporate before they can reach the surface due to the intense heat. The thick clouds obscure our view of the surface, making it difficult to study the planet from Earth. However, scientists have been able to penetrate the clouds using radar and other imaging techniques. These observations have revealed a world of volcanoes, vast plains, and towering mountains. The sulfuric acid clouds are just one more example of the extreme and hostile environment that exists on Venus. They serve as a reminder that while Venus may be Earth's twin in size and mass, it's a very different world in terms of habitability. Beneath the thick atmosphere lies a surface shaped by intense volcanic activity. Venus is home to thousands of volcanoes, some of which are thought to be still active today. These volcanoes have played a significant role in shaping the planet's surface and atmosphere. The surface of Venus is relatively young, geologically speaking. It's estimated to be between 300 and 600 million years old. This youthful appearance is due to the planet's resurfacing through volcanic activity. Lava flows have paved over older features, creating vast plains and volcanic features. Among the most striking features on the Venusian surface are the shield volcanoes. These massive, gently sloping volcanoes are similar in shape to the Hawaiian Islands. They form from eruptions of fluid lava that spread out over large areas. The volcanic activity on Venus has also played a crucial role in shaping the planet's atmosphere. Volcanic eruptions release large amounts of carbon dioxide and other gases into the atmosphere, contributing to the runaway greenhouse effect that has made Venus the inferno it is today. Despite the challenging conditions, scientists have sent numerous missions to study Venus. These missions have provided invaluable data about the planet's atmosphere, surface, and magnetic field. One of the earliest missions to Venus was NASA's Mariner 2 spacecraft, which flew past the planet in 1962. Mariner 2 confirmed the existence of Venus's hot surface temperature, shocking many scientists at the time. In the 1970s and 1980s, the Soviet Union sent a series of Venera probes to Venus. Several of these probes successfully landed on the surface, capturing the first images from the Venusian surface. The Venera missions provided valuable data about the planet's atmosphere and surface composition. NASA's Magellan spacecraft, launched in 1989, used radar to map the surface of Venus in unprecedented detail. Magellan's observations revealed a world dominated by volcanoes, lava flows, and impact craters. The extreme conditions on Venus's surface make it highly unlikely that life as we know it could exist there. However, some scientists have speculated about the possibility of life in the Venusian atmosphere. High in the Venusian atmosphere, where temperatures and pressures are less extreme, there is a layer where conditions might be more hospitable. Some scientists have proposed that microorganisms could potentially exist in this region, where they might find refuge from the harsh conditions below. These hypothetical microorganisms would have to be extremophiles, capable of surviving in environments that are toxic and acidic. They would also need to be able to tolerate the intense ultraviolet radiation from the sun. While there is no direct evidence to support the existence of life in the Venusian atmosphere, it's an intriguing possibility that warrants further investigation. Despite the challenges, Venus continues to fascinate scientists. Several future missions are planned to further explore this enigmatic world. NASA's Da Vinci Plus Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging Plus mission, set to launch in the late 2020s, will study the composition of Venus's atmosphere during a descent to the surface. Da Vinci Plus will provide valuable insights into the history of Venus's atmosphere and the processes that led to its runaway greenhouse effect. The European Space Agency's Envision mission, also slated for launch in the late 2020s, will use radar to create a high-resolution map of the Venusian surface. Envision will investigate the geological history of Venus and search for evidence of past water on the planet. These future missions will provide a wealth of new data about Venus, helping us to better understand its evolution, atmosphere, and potential for hosting life. Studying Venus is not just about understanding our planetary neighbor. It also provides valuable insights into our own planet. By comparing and contrasting Earth and Venus, scientists can learn more about the factors that make Earth habitable. Both Earth and Venus are rocky planets of similar size and mass. They formed in the same region of the solar system from the same materials, yet they have evolved to become dramatically different worlds. The key difference between Earth and Venus lies in their atmospheres. Earth's atmosphere is primarily nitrogen and oxygen, while Venus's is dominated by carbon dioxide. This difference in atmospheric composition has led to vastly different surface temperatures and conditions. By studying how Venus's atmosphere evolved, scientists can gain a better understanding of the processes that regulate Earth's climate. Venus serves as a stark reminder of the delicate balance that allows life to flourish on Earth. Its runaway greenhouse effect is a cautionary tale of what can happen when greenhouse gases accumulate unchecked in a planet's atmosphere. While Earth is not in imminent danger of becoming like Venus, the lessons learned from our sister planet should not be ignored. The increase in greenhouse gases in Earth's atmosphere due to human activity is a serious concern. By studying Venus, we can gain a better understanding of the potential consequences of unchecked climate change. This knowledge can help us to make informed decisions about our own planet's future, ensuring that Earth remains a habitable home for generations to come. Despite its hostile environment, Venus continues to captivate our imaginations. Its mysterious beauty, shrouded in thick clouds, has inspired artists, writers, and scientists for centuries. As we continue to explore our cosmic neighborhood, Venus remains a tantalizing target for scientific exploration. Its secrets hold valuable clues about planetary evolution, atmospheric dynamics, and the limits of life in the universe. In the years to come, future missions will undoubtedly unveil even more wonders about this enigmatic world. Venus, our sister planet, holds a mirror to Earth, reflecting both our past and our potential future. It's a reminder of the fragility of our own planet and the importance of continued exploration and scientific discovery.